Have you ever looked up at the night sky and wondered if we are truly alone? That question has driven us to build ever more powerful tools to explore the cosmos. For centuries we relied on our eyes, then telescopes, and now, a golden eye in space, the James Webb Space Telescope. This telescope is changing everything we thought we knew about our place in the universe. The cosmos is vast, billions of galaxies, each with billions of stars. For years, we could only guess if other stars had planets like our own. These distant worlds, called exoplanets, are incredibly hard to find. Small, dim, and far away. But our curiosity led us to new ways of looking, building observatories on mountains and launching telescopes into space. Each step brought us closer to answering, are we alone? The James Webb Space Telescope is our latest, greatest leap in this journey. Imagine trying to spot a firefly next to a searchlight from miles away. That's the challenge of finding an exoplanet. The light from its parent star overwhelms the faint glimmer of any orbiting world. For decades we could only infer planets by watching stars wobble or dim, but seeing them directly required a new kind of eye. We needed to see in a different kind of light, infrared, invisible to us but carrying the secrets of distant worlds. The story of our universe is written in light, and the farther we look, the further back in time we see. The James Webb Space Telescope is not just a telescope, it's a time machine. Designed to capture the faint ancient light from the first stars and galaxies, it's also revolutionizing our search for life elsewhere. Its recent discovery has sent a shockwave through the scientific community. We are closer than ever to finding a world that might harbor life. The universe is no longer just a distant mystery, it's a place we're beginning to explore in detail. With JWST, we're not just looking, we're listening for the echoes of life across the cosmos. The search has never been more exciting. And now, the universe is starting to answer back. For over 30 years, the Hubble Space Telescope was our window to the universe, revealing breathtaking images and cosmic wonders. But Hubble had its limits. We needed a successor that could see farther and clearer. Enter the James Webb Space Telescope, the most powerful and complex space observatory ever built. A collaboration between NASA, ESA, and CSA, JWST's mission is to solve mysteries in our solar system, study distant worlds, and probe the origins of the universe. Unlike Hubble, which saw mostly visible and ultraviolet light, JWST is tuned to the infrared, opening a new cosmic landscape. This allows us to investigate the cosmic dawn, when the first stars ignited. The light from these ancient objects has traveled over 13 billion years, stretched into the infrared by the expanding universe. JWST's giant mirror and sensitive instruments are designed to capture this faint glow, giving us a direct view of cosmic creation. But JWST's significance goes beyond cosmology. It's our best tool yet in the search for habitable worlds. By studying exoplanet atmospheres, it can search for biosignatures, gases like oxygen, methane, and water vapor. Finding such signatures would transform our understanding of life and our place in the universe. The James Webb Space Telescope is not just another telescope, it's a quest for answers to our deepest questions. And it's only just begun. To grasp JWST's power, we must understand infrared light. Our eyes see only a sliver of the electromagnetic spectrum. Beyond red lies infrared, invisible but felt as heat. Many cosmic wonders, newborn stars, galactic cores are hidden behind dust that blocks visible light. Infrared light passes through this dust, revealing what was once invisible. JWST can now witness stars and planetary systems forming inside dense nebulae, unlocking secrets of our own solar system's birth. The universe is full of hidden rooms, and JWST has the key. The expansion of the universe stretches light from distant galaxies into the infrared, a phenomenon called redshift. Without an infrared telescope, this ancient light is lost to us. JWST was built to capture these faint, red-shifted signals from the dawn of time. To do this, it must be incredibly cold. Any heat from its own instruments would blind it to faint cosmic signals. That's why JWST has a massive sunshield, blocking heat and allowing it to cool to minus 233 degrees Celsius. This extreme cold is essential for its unprecedented sensitivity. JWST is a marvel of engineering, designed to give us the clearest view of the infrared universe. With it, we can finally see what was once hidden in the cosmic dark. Launching JWST was just the beginning. Its destination, the second Lagrange point, or L2, 1.5 million kilometers from Earth. Here, the gravitational forces of the Sun and Earth balance, allowing JWST to stay in a fixed position. The journey took 30 days, with the telescope unfolding itself in space, a delicate, high-stakes process. L2 offers two key advantages: a stable, cold environment and an unobstructed view of the cosmos. By keeping the Sun, Earth and Moon behind it, JWST's sunshield blocks their heat, allowing the telescope to reach its required temperature. At L2, JWST can observe deep space continuously, gathering light from faint, distant objects. This stable orbit and clear line of sight make L2 the perfect perch for our new cosmic eye. In this quiet, cold place, JWST is ready to uncover the universe's secrets. On August 10, 2025, the James Webb Space Telescope team announced a discovery that electrified the world: a remarkable exoplanet named Xylos. Orbiting the red dwarf Gliese 1214, about 48 light-years away, Xylos is unlike any planet we've found before. JWST's data suggests Xylos is a water world, almost entirely covered by a deep global ocean. It's a super-Earth, larger than Earth but smaller than Neptune, with a radius 2.5 times Earth's and a mass 8 times greater. Previous telescopes couldn't penetrate its thick, hazy atmosphere, but JWST's infrared spectrographs revealed its secrets. Using transit spectroscopy, astronomers analyzed starlight filtering through Xylos's atmosphere as it passed in front of its star. Each molecule absorbed specific wavelengths, creating a chemical barcode. JWST detected an overwhelmingly strong signature for water vapor, so much that only a vast ocean could explain it. The data was clear. This is the most definitive evidence ever found for a water world outside our solar system. Xylos's discovery marks a new chapter, moving from simply finding planets to truly understanding them. We're no longer just cataloging worlds, we're beginning to characterize them in detail. The search for life has taken a giant leap forward, and Xylos is just the beginning. The story of Xylos is extraordinary. It orbits its star closely, completing a year in just 38 hours, and is tidally locked. One side in perpetual day, the other in endless night. The day side is scorching, but the thick atmosphere may distribute heat, creating temperate zones. Water could make up 25% of Xylos's mass, compared to Earth's 0.02%, suggesting an ocean hundreds or thousands of kilometers deep. The pressure at the bottom would be immense, possibly forming exotic ices. JWST also detected methane and carbon dioxide in the atmosphere, gases influenced by biological and geological activity on Earth. While not proof of life, these are the clues we hope to find on a potentially habitable world. Xylos is a natural laboratory for studying the conditions that might lead to life, but it's still an alien world: high temperatures, crushing pressures, and a volatile red dwarf star. Future JWST observations will search for other biosignature gases like oxygen or ozone. The discovery of Xylos is not the end, it's the start of a new investigation. Each new observation brings us closer to understanding what's possible. The universe just got a little more interesting. To appreciate the discovery of Xylos, compare JWST to its predecessors. Hubble's mirror is 2.4 meters. JWST's is 6.5 meters, giving it 7 times the light collecting area. More light means JWST can see fainter, more distant objects and gather data faster. This is crucial for techniques like transit spectroscopy, where only a tiny fraction of starlight filters through a planet's atmosphere. Hubble could detect a thick atmosphere on Xylos, but not its chemical makeup. JWST's advanced spectrographs and cold, stable location at L2 make detailed atmospheric analysis possible. Its instruments are exquisitely sensitive to the wavelengths where key molecules leave their fingerprints. JWST was built for this science, turning blurry hints into sharp portraits of distant worlds. This leap in capability is what made the discovery of Xylos possible. The universe is coming into focus as never before. The discovery of Xylos marks the dawn of a new era in astronomy. We're moving from simply finding planets to understanding what they're like. With JWST, we can build a catalog of worlds with different atmospheres, climates, and chemistries. This lets us place our own planet in a broader cosmic context. JWST will observe hundreds of exoplanets, building detailed portraits of their atmospheres. This flood of data will keep scientists busy for years, leading to discoveries that challenge our understanding. The implications go beyond science. JWST's images and data capture the public imagination. Seeing a water world 48 light-years away changes our perspective. The universe feels less empty, more full of possibilities. JWST is our storyteller, and its greatest tales are yet to come. The James Webb Space Telescope is a monumental achievement in our quest to understand the universe. Its discovery of Xylos, a super-Earth water world, shows the power of its new capabilities. By reading the chemical barcodes of distant worlds, JWST is transforming speculation into evidence. We stand at a pivotal moment, armed with a tool that can finally answer ancient questions. The universe has held its secrets for billions of years. Now, we have a key. The discovery of Xylos is just the beginning. As we peer into the darkness, what other wonders are waiting to be found?